Okay, hello students. Today I'm going to teach about the tutorial 3 motion in circle. Okay, so let's see what is the question in this tutorial. Now the first question is about the diagram. It's showing a system where the stone will whirling around in a horizontal circle of a radius of 80 cm, and the stone have a mass of 90 gram and it complete 10 revolutions in a time of 8.2 seconds. So the question required to calculate the time taken for one revolution, the distance traveled by the stone during one revolution, the speed of the stone as traveled in the circle, and for the centripetal acceleration of the stones, and finally the centripetal force on the stones. Finally, part B and part C is required to understand some concept, where part B is required to state what provides the centripetal force on the stones, and part C what is the angle between the acceleration of the stone and its velocity. Okay, so now let's solve the question part A first. Okay, let me call out my pen. Wait, I call out my pen. Yes, my pen is called up now. Okay, part A, first question. Okay, so it's required to find the time for one revolution, where it actually is our period. So from our definitions, the period is the time that require for one revolution. So it given here is the time for 10 revolutions is 8.2 seconds. So in that way, we can calculate that for the time for one revolution is divided by 10. So it means we have 0.82 seconds, which is the time for one revolution, which also our period. Now, second question. Second question requires to find what is the distance traveled for one revolution. Now, it's very simple. It's very straightforward. As we know that the distance traveled for any angles is defined as r theta, where my r is the radius. Now, be careful here. The question given here is 80 cm, but we need it in meter, or we must calculate in SI unit, where is 0.8 meter. You have to convert it. Okay. Now, times the angle that traveled by the stone. Okay. Now, if for one revolution, the angle traveled by the stone is actually 2 pi. Okay, which is a 360 degree. So now pay attention here. Whenever we want to calculate the motion in circle, we have to use it in radians. So this is must be in radian. Okay, you cannot use a degree. Okay, so finally we get 1.6 pi. Okay, now what is the unit here? The unit here will be meter. Okay, will be meter. Okay, now third part. Third part require you to find the velocity. Okay, now the velocity of this system. Okay, now again, so from the definition we know that the velocity of these circular motions is all the will be a constant. Okay, so the speed will be the constant. Sorry, it's not velocity, it's the speed. So the speed will be constant all the time. Okay, so for our definitions, speed is equal to r times omega. Okay, now what is omega? So omega will be defined as 2 pi times the f, where f is the frequency. So, but I don't have frequency here, but I have a period. Still remember, question A, part 1, our period is, sorry, I call out, okay, is 0.82 second. Okay, 0.82 second. So, straight away we can convert it into this form. Okay, so we have 2 pi times 0.8 divided by 0.82. Okay, so you can use a calculator, calculate it, and you will get your answer at this. So, and the unit will be meter per second. Okay, meter per second. Now, in question number 4, it wants you to find the accelerations. Okay, the centripetal acceleration of this system. Okay, So for our definition, again, A will be equal to R omega squared. Okay, now if you don't want to use this, you can use V squared over R. So it depends on you. Okay, so if I'm using V squared over R, I will straight away use the answer from part 3, 6.126. Okay, square it up, divided by R. So the R will be the distance, sorry, the radius of the motions, okay, of this circular motion. Okay, sorry, will be equal to 46.98. Okay, so the unit will be in -2. Okay, for my pen first, so my pen will be here. Okay, so now question number 5. So the question number 5 requires to find the force, centripetal force of the system. So we know that from our definitions, force is equal to ma. Okay, F equal to ma. Now what is your m? Okay, now the m is given here is 90 grams, so be careful, we need it in SI unit, so we have to convert into kilogram. Is 0.090 kilogram times the acceleration you just calculated in question 4. Okay, 46.98. So you will get your answer as 4.23, and the unit will be in Newton. Okay, so now in part B asks you what will provide to the centripetal force. So you have to remember that centripetal force will not come in free. Okay, there will be no free lunch in this world. So it means that something must provide it to so that it will become the centripetal force. So in this system, it's very obvious that the centripetal force is provided by the tension of the string. Okay, so the tension of the string will make the stone change the directions, okay, so that's why it will act as a centripetal force. Now part C, the question asks you what is the angle between the velocity and the centripetal accelerations. Okay, now I will draw you a simple diagram here. This is center of the circle, so this is a circle and this is the stone. Okay, now pay very attention here. So you know that the stone will be whirling in this direction, so where the velocity speed will be in these directions. Okay, now where is the centripetal accelerations? So it will always point towards to the center of the circle. So where this is my A and this is my velocity. So it's very obvious that the angle between the velocity and the centripetal acceleration is 90 degree.